Continuing on in section 6.7, page 2 of the notes, see page 395 in the book for the helpful reminder about what to do with negative exponents in the numerators and denominators. A negative exponent moves the base to, it switches its position from the numerator to the denominator or from the denominator to the numerator. And then we're going to move on to some operations and more involved problems. The instructions say to simplify each exponential expression, assume that variables represent non-zero real numbers. So the variables are not going to be zero because we can't divide by zero. That's all that that means. Okay. It means we're not trying to divide by zero because that's undefined and then nothing would work here. Okay, so looking at number 32 here on page 403, you've got in parentheses 5x to the negative 7th times 3x cubed. Now, we're going to be dealing with the numbers separate from the variables, the unknowns, because we know how to deal with multiplying numbers, and we're practicing how to multiply and divide variables and their exponents, specifically negative exponents in this section. So, and there's lots of different ways you could do this problem. One way would be to, again, just deal with the numbers first as 5 times 3, and then you've got x to the negative 7 times x cubed. So to really just focus on the numbers, that gives you 15. Focus on the variables, then you've got same bases being multiplied, x, and so you would, and they're being multiplied, so you would add the exponents, negative 7 plus 3, which is a negative 4, so you'd have 15x to the negative 4, and what we're learning about is that negative then does the job of flipping, and notice it only applies to the x, it does not apply to the 15. The 15 stays up top, the negative pushes that x to the denominator, the opposite spot, keeps that 4, just the negative did its job of flipping that x, and our final answer is 15 over x to the 4th. Now, another way to look at this problem would be to say, okay, let's take care of the negatives first, okay? Because we can deal with what's inside parentheses first. Order of operations says we can do that. So instead of 5x to the negative 7, I could write this as 5 over x to the 7th. Again, the negative does its job of pushing the x to the other side of the fraction. It's on the top right now, as if it were over 1. It pushes it down to the bottom. Notice the 5 is not affected. If the negative 7 was outside this parentheses, then 5x would move down. But right now it's just the x that moves to the bottom. The negative causes the x to the 7th to move to the bottom. And then we'd be multiplying by 3x cubed, or you could think of it as 3x cubed over 1. And now you can see that the 5 times 3, 15, does stay on top. And you've got x cubed on top and x to the 7th on the bottom. And when you imagine writing out x times itself 3 times on the top and x times itself 7 times on the bottom, you could imagine that those 3 of those would line up and cancel with each other, leaving no x's on the top and leaving 4 on the bottom, which is what we have. Or you could do your, again, your, pardon me, your rule of top minus bottom exponent. 3 minus 7 is a negative 4, and you're back to what we were looking at originally. So there's lots of ways to think through this problem. For some people, that's what makes it confusing, because there's more than one way to do these problems. Is there a way that's better than another? That's going to depend on your brain and how it connects information. How are you going to know? You're going to have to do a lot of problems until you feel confident in what you're doing. And you'll be confident once you see that you're getting answers consistently right. There's fewer and fewer mistakes. So try all these ones in the notes. Try all the odds that I've assigned, and then go after even more practice problems if it's not clicking yet, okay? Push through until this really starts to become less awkward and more natural for you. Let's look at number 52. What's different about this one? I'll give you a moment to kind of think about that. So one of the things I noticed is we've got a parentheses here, and there's a power raised to another power. Now, we've seen that before. We just haven't seen it on top of a fraction involving a negative exponent in the denominator. So it's kind of bordering on a practice plus here. We've got a lot going on. Again, lots of ways to start this problem, okay? And lots of ways to think about it. We can use the definition, we can use the rules, we can deal with the negatives first. There's lots of ways to go about this. I think I want to simplify the top first. Now, this is not the way to solve this problem. Lots of ways to solve it. So if you have a different gut instinct, follow that instinct and see where it takes you. Then you'll know if you're on the right track or not. That's why I assign the odd problems, and that's why we do the evens and the notes together, so you can see if you're on the right track and get yourself ready to face some on your own that are brand new. Okay, so I think my gut instinct today is to go ahead and deal with what's happening on the top. There seems to be a lot going on. So I can either recall the powers to power rule, which means that I'm going to apply that third power to both pieces, to the 4 and to the y to the 5th. Or I could, by definition, write this out 3 times. 4y to the 5th times 4y to the 5th times 4y to the 5th. And then multiply the 4s, add up all the 5, or add up all the y to the 5ths. Either way, I'm going to get 4 cubed, which is going to be 64, times y to the 5 times 3. That's the applied when you get a power to a power, you multiply. So it'd be y to the 5th times y to the 5th times y to the 5th. That'd be 5, 10, 15. So you can only get there by multiplying. And then this whole thing over y to the negative 4. So I've got 4 cubed y to the 15th. And that's going to be 64 y to the 15th over y to the negative 4. Now, I can apply my negative here and move the y to the 4 up top. I could apply my rules of exponents that says when I'm dividing by the same basis, I would take top minus the bottom. If I were to do that, it would be y to the 15th minus the negative 4. I'm taking my top exponent minus my bottom exponent. And that would be 64 y to the 15 plus 4, which would be y to the 19th. Notice if I had applied my, if I'm right here at 64 y to the 15th over y to the negative 4, right here, if I applied my negative exponent, that would move this y to the 4th to the opposite location. Nothing else changes here. The 64 y to the 15th stays right there, but the y to the 4th now moves up to the top. And if I have 15 and another 4, 15 plus 4, again, I'm at 64 y to the 19th. So in one sense, you've almost got a built-in check system because there's lots of ways to get to the same answer. On the other hand, you have a lot of freedom to figure out how you are best at solving these problems. Do you like to deal with the negatives first and get all those out of the way? Do you like to deal with the power, the rules of exponents? Do you like to use the definition and write it all out? Lots of freedom of expression, so to speak, here in this part of mathematics. So enjoy that, embrace that. Again, the more you practice these types of problems, the more you can get your hands on and do them, the sooner it's going to start clicking and start to make sense, and it'll feel more natural.